Welcome back to my YouTube channel. This is Mechanotechnics N6 traction and rail, right? So we've given example one says a locomotive with a mass of 60 tons, and we've given a dot separation comma 70% of which is supported by the wheel. 70% by what? By the wheel. Check note, by the wheel. Destructive resistance is Newton per ton. Newton per ton. Ton its mass is Newton over mass. You must multiply by mass. It's in Newton over mass. They simply say Newton over mass. To cancel this, you're supposed to multiply by the tons, whereby it's obviously, and the coefficient of friction between the wheels and rail is 0.25. Is coefficient of friction. If the locomotive travels at a constant speed, the velocity they've given v there. On the level, what is important again, they check it's a level track. Level. Calculate A, the locomotive tractive effort. We want TE there. Locomotive tractive effort. Alright. Check, and then we have given 70% of what? Of a driving wheel. If you have given that, guys, from your N5, if you still remember, I know that you still remember that. We must know that, okay, we have there, you can say A, we want structive effort. Structive effort is given by TE, whereby this will be equals to the mass of the locomotive, guys, multiply by, remember now, we'll multiply this by 10 to the power of what? Of multiply this by 10 to the power of what? Of that 3 there. All right, we have that, because now check the locomotives there. It is because the guys, because they will multiply by this, because the locomotive is, because the locomotive there is given in tons, the mass actual. Okay, let me just do like this. Let me not include this. It's locomotive, right? Multiply by coefficient of friction, multiply by gravity, multiply by what? By the percentage. But that percentage that we calculate, but what? It's a percentage. Multiply this by the percentage of what? Of the mass on driving what? Driving wheels. All right, we've given that. You will see something. We'll talk about driving wheels then. Are we together? Now we know that there we've given that. As you can see, guys, we are given that. We've given now our locomotive there. As you can see, we are given our TE. We have given everything there. Let us substitute our thing there. All right. The formula is supposed to be like this, but now the mass is given. Your convection, your mass is in ton. The mass supposed to be in kgs. So you must know that 1 kiloton, we must know that 1 ton is equal to 1000 kgs. So if you have 60 tons, you want this, you cross multiply, you see, you multiply, this will be 60 multiplied by what? Times 10. This is the same as times 10 to the power of 3, whereby that is why you're supposed to substitute this. Now it will be what? In kgs. All right, so that is what we're supposed to use there. The mass, since it's given in ton, will be 60 multiplied by 10 to the power of positive what? 3 for the convection, multiplied by the coefficient there between the rails. The coefficient given is 0.28. You multiply this by your coefficient 0.28, multiply by gravity is 9.81, multiply by the percentage. That percentage, the percentage there on the you are given them 70% of the supporting by the driving wheel, percentaging on what driving wheel. Here it's a percentage is what is 70%. 70% is the same as 70 divided by 100, which is same as 0.7. So we'll multiply by that there. All right. So multiply this by 70. So, by 0.7. It's the same as 0.7. When you divide that by 100, now you will punch this. Therefore, we'll have our TE there will simply equals to what? Our locomotive tractive effort will be 115.4 watt there times 10 power of 3. But let me just write it in kilonewtons. So this is what we have there in kilonewtons. We have it that in kilonewtons. All right, what about B now? Let's see what B says. Says determine the power developed by the locomotive if transmit efficient of 75%. Of 75%. All right, want the power. We know that power, guys, we have given a constant velocity. Power, we know that power is equals to what? To force multiplied by velocity. We use this formula if you're given what? A constant, if you're given constant velocity. I'm meaning that you're not given an average, you've given one velocity. Also, you've given what? A constant force. Talking about the force does not change, constant, right? If they were saying that the train initially start from rest 0 meters per second, then goes to final velocity, you don't use this. This is an average. If you have two velocities, we call them average. But when the constant, you're supposed to have one velocity, and the constant does not change. We have to have a constant velocity and a constant what? Constant force. So we can use this. But however, if now we are given, this is a power, but this power, if we are given things like that is force multiplied by velocity, if we are given efficiency, we divide this by the efficiency. We divide this by what? By efficiency. So this is our power. But now this force is measured in Newton. However, as we've given a tractive effort, that will replace by that with TE. We'll replace that with TE. Right. So our power will be given by TE, tractive effort multiplied by velocity. Now divide by efficiency since we have what? The efficient. All right. Hopefully we are together there. So this is what we're supposed to have. So this is what you're supposed to note. This is what you're supposed to have. All right. We still have B. By the way. Still have our B there. Still have B. All right. All right, then what is TE? TE is this one. It's 115.4 kilonewton times. All right, if you substitute this in kilonewton, if you don't change, that means your final answer must be in kilowatts because you substituted this in kilowatts. But if you use it in watts, if you say times 10 to the power of 3, then your answer must be in watt. It's up to you. Okay, I've substituted this in kilonewton because that is in kilonewton. Since I will substitute this in kilonewtons, then my answer is supposed to be what? Must be also in what? In kilonewtons anyways. So let's check. We need the velocity. It says travel at a constant. Yes, you see, I've talked about at the constant. I've said to calculate power if you have given a constant. That formula, use it when you have given a constant speed. Constant speed and velocity is one thing. It's a constant. Here is 40 kilometers per hour. Now you're supposed to convert that. Is our speed is supposed to be in meters per second, is measured in that, not in kilometers per hour. Now we have when we substitute this, our velocity is supposed to be what, measured in meters per second, but we've given in kilometers per hour. Kilometers per hour. All right. Kilo is the same as times 10 to the power of what? Is the same as 1,000. Remember, 40 kilometers per hour. But hour is the same. Hour is the same. Is the same as what? Hour is the same as what? As 60 times 60 in seconds. Remember, in 1 minute, you will have 60 seconds. 60 seconds. Are we together? In 1 hour, we have 60 minutes. That's the thing now. So you see, you can convert now. Since you know this, you can go, we know these two things. You can start here from the bottom one, so that you don't have to memorize this. You don't have to memorize it, because you must know that okay, since we say in 1 hour we have 60 minutes, so we've given what? There we've given 40. We know that kilo, we've already converted kilo. We've given hour per hour. So we know we have this in hour, right? But what about 60 minutes? We know that, isn't it? We want to go 2 seconds, right? We use this proportion now that says 1 minute. We'll use the top one. 1 minute is equal to 60 seconds. 1 hour, in 1 hour we have 60 minutes. So we have the 60 minutes. We want to know the seconds. Cross multiply. You multiply that, x will be 60 multiplied by 60. So this will be 3,600 seconds. So that is how you convert. Do not cramp, but anyways, you must know you multiply 1 times 60 that. So the velocity, or the fastest way is just say you divide this. The fastest way is 3.6, guys, from N4. You remember, the fastest way, you divide that by 3.6, the fastest way. All right, divide that by 3.6. If you say 40 divided by 3.6, you'll have 1 meters per second. Someone can use the straight method. You can just someone can say 1,000 multiply by what? By 40 divided by this. Will obtain the same answer. Your seconds there, 3,600 seconds. So it's one and the same thing that will convert, will obtain our velocity there. All right, so anyways, nevertheless, the stories won't end. Multiply there, we have the velocity 1,111 divided by efficiency. They say it is 75, so 75 is the same as 0.75. Punching this, therefore we'll get that the power will be 1709 kilowatts. Why kilowatts? I substituted this in kilowatts anyways. Okay, there we have it. No problem. All right, what do we have now again? Let's check. We have things like C there says the acceleration required to accelerate the locomotive from, now they say from, that means this, we take it as a initial velocity. From, needed to accelerate, from is needed to accelerate from that. Remember, if it's needed, you must have the force of acceleration. You cannot have, all right, needed to accelerate determined from that. Okay, so all right, let's go and have our C. We want the acceleration, but this is a level track. They've said this is a level surface. If you have level surface there, you have your wheels anyways. I will just throw that. All right, so guys, here remember you'll have, since it is horizontal, you'll have TE that will take place there, the force that's caused by the engine, the destructive, but it's here, will act there, will act in that direction, I mean there. All right, will act there. Then in the opposite direction, remember, since we have the friction there, we'll have FR, isn't it, the rolling resistant total. Then we have here FA, you must know, will act in the opposite. The force that required to accelerate this is the force that is required to accelerate this. So we can, you know this, check the vectors. This is pointing in the same direction. So we'll have TE will be the same because these they are pointing in the same direction. You add them. FR plus FA is pointing where? In the same direction. So, but now the acceleration will get it here in the accelerating force. So if we make accelerating force the subject, you will take this to the other side. It's same like TE minus FR. This is our rolling resistant. But the rolling resistant, it's always, it's my fear not given, it's a mass, obviously, of this mass of this locomotive, mass of the locomotive, not of the track, no, of the locomotive first, because there's a difference between track. We'll discuss about the tracks. You can calculate the number of tracks. We'll talk when we are calculating about tracks. Remember, this is the locomotive. If you have given something like this here, you must know we have maybe there. Must understand this. Then here we have these things. Now these are tracks. What do are is like, do you call that things tracks? You see those trailers like this. Some of them they put coils, the traveling coils. This we call these tracks. Those are tracks, but this is a locomotive. So we'll use the mass of the locomotive for now in this time. This we call these tracks. All right. We can calculate they can ask you sometimes to calculate the number. How many are they? The number of that, of the tracks. Now we have 3 anyways. We are not here, we are not there, we are not there for now. Let us continue where we left. We are not there, we are not there, we are not there. All right, there will be locomotive. Remember, resisting is FR is taking place where? Here in the rolling, here in the tires. So we'll multiply that by, obviously, by what? By the R, by the rolling resistance. Remember, it's appearing here. The tires, they are rolling. We multiply by that rolling resistance there. All right, so we have our FA. TE we calculated there on the top. We got that on the top. It was 1,1. I still remember, 4, which was in kilonewtons, times 10 to the power of what of 3 minus. Now this we said the mass of the locomotive, it was 60. It was what? 60. We've given the mass of the locomotive. The mass of the locomotive, it was what? 60 what? 60 tons. Now, why do we multiply by this? Not always you're going to multiply. You must be aware of the units. You check our rolling resistance, the tractive rolling resistance. This is the tractive rolling resistance. It's in 100 Newton per watt per ton. We've given that in what? It's 100 100 Newton per ton. So this mathematically, it's a fraction, is the same as 100 Newton divided by ton, isn't it? It's one and the same thing. To cancel this, remember FR must be calculated in Newton. Always the force, any force must be calculated in Newton. So you have to multiply this by the mass of the locomotive, but must be in ton. Since this is in ton, also this is in ton, must be in ton. So if you multiply that, you must know that the tons and tons will cancel. So if you multiply the mass there we have given, there it is 60. We've given our 60 tons. So tons and tons will cancel, mathematical will be left with what? With Newton. So 60 multiplied by that. So sometimes if they give you the mass like this, mass maybe in kg, the mass can be 60 kg for example. Make sure you match up the units. Let's say now the rolling resistance of tractive rolling resistance is 100 Newton per ton. You cannot just multiply. The units, they are not the same. You're supposed to convert this to become in tons. You have to convert this to be in tons so that the SI units will be the same, or convert, you have to convert that to be the same. Anyways, without wasting time, we'll have there our mass is 60 multiplied by rolling resistance there of 100. We've seen that will cancel. So we'll have FA. All right. Then multi punching this, we're supposed to get that. Punch there, guys. We are together. All right. We have 109400. Obviously must be in Newton. Now we want, remember this FA, guys, FA alone is given by mass multiplied by what? It's acceleration force multiplied by what? By the acceleration. We want the acceleration. So you make the acceleration, the subject will be FA divided by what? By that. So anyways, because we have this, since we have that, there's no need. Let's just go straight here. Since we have this now, I will just write here, but FA, but this. Oh, sorry, why I'm rubbing there. But FA, I know this FA, it's mass over that, over this. So we know that FA is mass over this thing, the same as that. Then A we divide by the mass, we divide this by the mass, 109400. Remember that it's in Newton. Your mass you divide by the mass, which is what is 60. But now don't remember it was in ton, it was 60 tons. But convected, mass is not in tons. Convected times 10 to the power of what? Of positive 3. Then we punch this. We'll nicely obtain our accelerating there. The acceleration will be 1,8. Obvious is measured in meters per second watt squared. This is our acceleration. All right. So we're done with that. So we have now, example 2 says a train. We have this, it's a train. Remember, train can be a truck, can be a train, but anyways, but it's a road structure. The train, given the train, can be a bus or can be a train. So if given a train, nevertheless, we have a train including locomotive, train including the locomotive, the train including the locomotive back. The mass has the mass of that locomotive is the one focus on most. It has a mass of 500 tons. If the mass supported on the driving wheel the mass, check now what the mass supported on the driving wheels, is 55 tons with coefficient of what we have there, with the coefficient of 0.8, a tractive resistance of 0.2 Newton kg. Check now, they said kg. Determine the time takes to obtain the speed from rest. This is an average. Talking about average. This is an average speed. We have two speeds. If you have two speeds, this is an average. This is an average. Then average. You cannot calculate the power using this formula. TE multiplied by velocity divided by efficiency, or even if you don't have efficiency, like this one, like this, cannot. If you use this, you'll be wrong. You cannot. This must be constant, but here we have average, two velocity. This velocity and this is an average, is not a constant speed. So if you don't have a constant speed, do not use this formula. Rather, multiply by a distance. Do not use this, you'll be dismally wrong. So we're together. Hopefully we are together. Anyways, let us go about and drill this and drill. Let us determine anyways the speed guide there. Anyway, we are given all of that there. So we have to determine the speed. All right. So this, guys, since we have the average, I've said since we have the average speed, that means what will appear here will be average power, because we have the average speed. It is not necessary, must be average, and an average you cannot use that formula. You're all right. Hopefully you get this. Anyways, let's have what we know. We know that TE Tractive is given by what? Remember, Tractive is a mass of the locomotive, right? Multiply by that. And if you have from multiply by the percentage of the wheel. But note, guys, this question, there are two. Please note this equation. There are two of this equation. You must know this. If you are not given the percentage, but then you have given the mass, remember you're supposed to given the percentage on the wheels. But rather, now they will give you the wheel. If they decide to give you the mass supported in the driving wheel. Remember, you're supposed to have the percentage in the supported. Supposed to have a percentage driving in the supported, isn't it? Supposed to have a percentage in supported multiplied by the percentage. But if you're not given that, this formula, guys, this formula will be TE now. Do not worry. You don't use the locomotive. You don't use the locomotive. You'll have your take will be mass of the wheels. All right, hope this you get this. Multiply by coefficient, multiply by gravity. Also, there's this one, guys, that we've discussed about, that the mass of the locomotive multiplied by coefficient, multiply by gravity, multiply by what? The percentage on wheels, what? If you've given the percentage. But if you've given the percentage driving wheel, you have given the percentage, use this one. We have two of these equation, guys. Take note, we have two. So this is applying on its own thing there. All right, do not confuse. All right, anyways, the mass there. Hopefully you have understood this. On the supported wheel driving is 55 watt tons. Okay, will be 55 now. Since tons will be, say, times 10 to the power 4 out of 3, converting at tons. Coefficient of friction is 0.28. Coefficient of friction, it is 0.28. Multiply now by Okay, it's 8 here. Let me just, all right, 0.28. Let me just multiply that by coefficient 0.28. Gravity is 9.81. Punching this, supposed to obtain, you have to obtain your stuff there. Then our TE therefore will be equals to what? 151,074. Obviously it's Newton. We have that. Now, you know the part of the game, Vulcan. You know the part of this game. The aim is to find, the part of this game. We want, why actually are we calculating this? Is because they said we should calculate determine the time. If we are given two velocity average, is this, you can use this formula. We are not given the distance, isn't it? Says velocity is equals to initial velocity plus acceleration time. We want this time. Making time will be v minus u divided by accelerating. So we're supposed to have this accelerating. Now the accelerating, the aim, most we have to get here to have the accelerating, because this we are given the accelerating. Now, because why do we calculate this? Because we know that TE, since it's a level surface, will be what? FA plus FR, as you have shown. So FA will get it here. So if we make FA the subject, we'll have TE minus FR. That is why we are calculating this TE. Supposed also to find, that is why we are doing all of that thing. Anyways, it's because of this guy. If it was not this guy of acceleration, we're going just to plug our things. But hey, guy, we are limited. So, anyways, you see what is the matter, how the cookie crumbles. So, we find TE. Let us find FR. As you can see there, our FR, rolling resistance. I said this, its mass, isn't it? Multiply by the rolling thing there. We discussed about that. But yay! Be careful. Hey, be careful. Why? The mass here. Be careful. The mass there is given by, hey guy, be careful. The mass is ton is 55. Remember, ton of the locomotive. This is the mass of the locomotive. Anyways, it's not just the mass. If I've just say mass, I suppose it's the mass of the locomotive. Yo, no, it's not 55. Oh God, so 55 is the wheeling driving. That must be locomotive. You see, I've taken this. This is wrong. Must be the mass of the locomotive. What is the mass of the locomotive? Is 500 tons. Oh, 500 tons. The mass of the locomotive. Yeah. Remember, you're multiplying there. 500 tons. But R, our rolling resistance, is 0.2 kgs. Let me check. Let me go there. I think I saw 0.2 Newton per kg. You see, 0 Newton. Newton per kgs. So check note, if we are multiplying this 0.2 Newton, this is per kg, multiplied by 500 tons. So, guys, this one cancel. Anyway, convert this or convert that. It's up to you. Let the SI units be the same. All right. Now I can convert that be careful. Don't just multiply because the formula says multiply. Do not just plug because you see the formula says multiply. You just multiply there. Don't just multiply, but check your units. So tons is the same as what is times 10 to the power of what? Of 3. Now this will be what in kg? It will be like that. The amounts will be in kg. So this and this will cancel. Anyway, this will same as 0.2 times 500 times 10 to the power of 3. This now will be in newtons because we have only what? The newton unit. All right. So supposed to multiply like that. Like that, guys. All right. 500 times 10 to the power of 3 multiplied by 0.2. All right. Then this what will give us, what will have obtained, what will obtain. Oh, 0.00000 Newton. Oh, what a nice value. One now, this, okay, we can substitute FA. We know that will be TE. Wait, our TE there. Here, this guy there. What about it? 15074 minus this guy. 1, 2, 3. With those zeros. 1, 0, 1. Minus 1, 0, 0, 1, 2, 2. Oh, here we have 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. Anyways, if you punch this, what you're going to obtain? Anyways, accelerating force will be what? Be 5, 1. 0.74 AVS. This is in Newton. This is our FA. Now have to find the accelerating guy. Get the accelerating the because we know that FA is equal to mass. We'll have that. Hey, if we make A is same as FA minus that, FA here is 51074. Mass is 500 times 10 to the power of 3. Alright, this now simply therefore accelerating will be equals to what? This is not our final value anyways. Yeah, these are just necessary steps we're supposed to take because now we can use that formula that I've shown you. I've shown you that time will be final minus initial velocity divided by acceleration. So this guy is the one that made us to take time going left and right. Hey. But what is that final velocity there? From rest, which is 0, from then this to obtain from 500 kilo, okay, 55 divide this by, I've shown you the first step method we just discussed. 55, just say 3.6, divide like that, divide that first, make it using 55 is what that we just peak velocity is 55 divided by 3.6. You'll get this to be 15278 meters per second. So that is what we have. T 15,278 minus 0. Acceleration is 0,102. Then therefore Mr. Time, you're going to be what? 149,7 82 seconds. That is our time. All right, we have this time now. How that? Any question that we have? Okay. That is what data now. Since we have this, I can say, can we just um can we calculate average power? I want you to understand. I can say let us calculate average power. Uh, Average power developed. Let us calculate average power developed. Average power developed. Average power developed. All right. So, sorry about that. Yeah. Oh, cancel this. No. Yeah, this guide has been. All right. I want us to left with in essential part accelerating this. Okay. Also this, let it fade away. It is no longer important that much, but the acceleration there will be important. Mario, I know it was 0.12. Okay, so let's find the developed power. So we have will be average because of the average speed, guys. We have two velocities. If you have two velocity, let me just say two velocity or speed, this equals to average, and then we'll have to calculate. We don't have constant speed. We cannot use this power multiplied by v. Remember, this is said is the same as, cannot use this force multiplied by v. Remember, we said this is the same as t multiplied by v. We cannot use this, it will be wrong. So we have to find average. So average, guys, will be given by te multiply now by distance. Take note, displacement there, divided by time. Where can we get this? This is the displacement. This distance is the same as s in your formula. S, if I can recall it well, it's s. Okay, why I say s? Because in our formula we have given that it to be s is this formula. S is equals to, we know that is a displacement u multiplied by time plus 1/2 acceleration t squared. You can use that as if you want. Initial velocity, say it is 0, is from rest, plus the will affect all of that, plus 1/2 acceleration, it was 0.105. The time obviously is the one that we just got recently of 19.782. We square this, punching this, supposed to obtain that the our distance 11444 comma 167, obviously meter there. So as you can see what we've obtained there. So we've obtained this. So let us try and substitute our things there. Still have now TE 151074 times distance 1144,167. The time is the one that we got. Simply just punch this, punched out. Then obviously this will be average power, nothing else but average power because of that. Okay, then will be 1154 kilowatts. All right. So what about that? That is what you're supposed to have there. It's your power. Number 3, example 3 says an electrical locomotive. An electrical locomotive are we together with a mass of 65 tons. Hulls, that means it's hulls, tracks, it's whole leg. I've shown you that hulls, tracks, here are tracks. Showing you example, they have wheels obviously. This is your locomotive here. This is the locomotive. These are trucks. Those trucks have that 400-meter long. All those trucks, they just give you trucks. The total is that trucks. All of the mass when you combine these trucks will give you that the total tracks there. You have that situation there. Just giving a picture so that you will see what the tracks along a level track. Okay, this is a level track. A constant, taking out constant speed. So here you can calculate a constant. Anyways, you can have a constant power if they want you to calculate the power because of a constant speed. You can have it if they wanted, but they did not ask us to calculate it. So what's the waste? Let us not calculate it. So the constant speed 55 kilometers per hour. The rolling resistance for locomotive and tracks is this. Rolling resistance for, check, they are sharing your English. Rolling resistance for the locomotive and tracks is this, is the same. They have the same rolling resistance. Kai, kite. This is 2. Oh, sorry guys. By that, sorry about that. Two. So anyways, you must know if you have a rolling resistance, guys. Rolling FR is appearing on the wheels. So we'll have 2 combination of the locomotive multiplied by rolling resistance plus is appearing in the if you have those tracks in the wheels, also the tracks they have the wheels. FR is appearing here, is acting there. So plus we're supposed to add because including the one of the tracks plus now the mass of what of the tracks multiplied by R. This is what we have. But this is the same. If you want, you can take out as a common factor. Your FR can be ML plus M of the track multiplied by R. Can use this anyway. You see there. Anyways, we are not there for now, but we are there. Let us just continue things. Nevertheless, talking or always time. Anyways. Okay, we have that the coefficient of and the coefficient of the house between the walls and the real. Okay, here it's a coefficient. It says calculate the destructive effort of the locomotive. Okay, it's of the locomotive, not of the tracks, but of the locomotive. All right, TE is the one that we want. We want you, Mr. TE. Okay. TE, we know that is mass of the locomotive multiplied by what? By coefficient, gradient, all those things. Coefficient, okay, gravity multiplied by, we don't have the percentage. We're supposed to say by percentage, but we don't have, anyways. We don't have that. What's the use to substitute what we don't have? Okay, TE. The mass of the locomotive we've given there, we have seen that it was 65. Okay, here mass of the locomotive, so at 65 tons there. All right, then of this is 100. of the tracks. Let's keep that in mind. Locomotive 665, but what tons? But this is a mass, must be in kgs, multiplied by 10 to the power of what of 3. Coefficient of friction, we've seen that was 0.28. Gravity is 9.81 anyways. So we'll have this, our TE there, be 178.542 kilonewtons. That is what we have. Then we have that. Oh, all right, that is what they wanted. Anyways, let's check B. They says the acceleration available to accelerate the motion and the tracks. Okay, we'll get that from this guy, from FA. But now you say, check the note, they say the accelerate what? Locomotive and the tracks. Locomotive combine, and not one thing, and combine. Combine the tracks. Combine. Here it's our tracks. Here we have the locomotive. Combine this. They said we should calculate what? Combine. The acceleration of the locomotives and the track. Acceleration of the locomotives and the track. So we're talking about F total plus F RT total, because this must be combination. We're talking about total. We've combined those things. Combine. So nevertheless, so TE, remember, is for this. We have TE. We've seen that because they're on the level surface, TE will be equals to FR as always, because now of the 2 we want TE. Remember, because TE will be acting that side, FR will be acting there, also FA will be acting that direction, obviously. Then TE will be acting there, that direction. So we know what we're supposed to do. We add, but now it's total because we're combining. We have two things there. We have total. I'm talking about total. It's both will be what? Total. FR is total. It will be total. Or let me just write total so that you'll understand. So we'll have FA not equal plus FA what? Total, guys. Total, not of the. So we'll get it from here, making that FA total will be TE minus FR total. So TE we have there 178,542 kilonewton times 10 to the power of 3. Yeah. So this is what we have. Kilonewton. But no, we'll convert that because I wrote that in kilonewton. It's TE. FR. What about FR? What about FR now? Yes. But anyways, We know that, guys. Fr, I've shown you, guys. This total is the combination of mass. We have two mass. Will be the mass of the locomotive is total plus the mass of what? The mass of the tracks. Of the track. They have the same. I said they have the same rolling rating multiplied by R because it's the same. Okay. We'll use that. We'll use that. We'll use that. That is what we'll use. Will be plus the mass of the locomotive plus the mass of the tracks multiply by R because it's the same. We have they said that they've said that to us. They've told us that. So we have our FAT K178,542 times 10 to the power of 3 plus what is the mass of the locomotive. Okay. Mass only, remember we've given 65 and 500. Mass, yeah. But it is what? Check note, this was in tons. So we're supposed to multiply this by times 10 to the power of what? So this, the mass, they will say more be 65 times 10 to the power of what? Of 3 plus the one of the tracks, which is 400. 400 was in tons times 10 to the power of what? Of positive 3. Must be in kg. Remember this, must be in kgs. So multiply. Or you can multiply outside, or you can say times 10 to the power of 3 here. It's fine anyways if you did that. All right, our R we have there. Now our R. Why I am using that? Let me check our R is given by what before I substitute. I said it's important to evaluate. Our R is given in what? In 50 Newton, in 150 Newton. So there's no need to convert here. There's no need to convert. Is what I've said. There's no need to convert because of our R also is in newtons. It's in tons. It's in tons. I can say plus. There's no need. 400. Remember, I said it's supposed to cancel. Our R we've given there. So as you have seen there, our R there. We have R, which is 1/5. Times 1/5. Right. All right. All right. I will take it. I will try and punch this. And have what about our F acceleration? Remember, this is total acceleration. All right. 178,542 times 10 to the power of 3 plus 65 times plus 400 times 1/5. What is that? Will obtain? I will obtain this. This will be there. 248,292 Newton. 248,292 Newton. All right, we want the acceleration. for now. But we know that F acceleration, we said F is equal to mass acceleration. But now it's a total, guys. We must, of the tracks plus the locomotive will be 2 mass there, because it's F total. It's F T total. It's a total. There will be what will have the mass of the locomotive plus the mass of the tracks multiplied by the accelerating. You want accelerating, so accelerating we divide by this both side. We'll have FA total, the one that we calculated in the top, divide by mass of the locomotive plus the mass of the tracks. Therefore total, there we got our accelerating is still there in my calculator. It is 248,292 divided by the mass of the locomotive. Remember the mass of the locomotive. And we took it. Now check note, it was in tons. Now it's a mass. It's a real mass. It's no longer resistant. What here? No longer traction resistant. Must be in kg. This 65. Or let me just multiply this by times 10. Must be in kg times 10 to the power of what? Of 3 plus 400 times 10 to the power of what? Of 3. Convert this. This must be in kgs. So let me punch this and see what I will have. So 248. Okay, let me, because it's still here on my calculator, let me just say fraction and divide by what we have there. This times 10 65 plus 1. I've obtained. Yay, there's something I forgot. Yes. There's something I forgotten. Okay. Oh, we have this. There's something I think I forgot. Okay, this is what I have. Okay, I've combined this TE. Here it is. Okay, it's TFFR. Here I've added. Oh, this is totally. You see, I've added. It's supposed to minus. Yo, guys. Yo, Martin. Here it's minus. What the mess is minus me. Suddenly I've added. Oh, anyway, I'll just subtract here. Just adjustment. Those are just adjustment. Let me now do these are just adjustment. 1718 comma 42 times 10 to the power 3 minus you see there 65 plus 400 times 150. Yeah, you see what I have now. 108792. All right, that is what I have now from my side. That is what I have. Yeah, this is pretty correct. Then let me scroll down a little bit. So I'll just replace here. I'll just have to erase here. F now will be this one, 108792. The mass there is still the one. I can see times 10 to the power of 3 65 plus 400. Why I did this, guys, because 65 times 10 to the power of 3 plus 400 times 10 to the power of 3, this is a common fact. I just took that as a common fact. So there, do not worry. Remember, must be now. This masses, they must be in. So let me find what will be the final value if I punch this now. The acceleration, say answer divided by times 10 to the power of 3 into 65 plus 400. Sorry about, got 0,2339, which is 0,234. Then my calculator 0,2339 like this, but if I round it off to 3, it will be 4, obviously meters per second squared. This is our acceleration. All right, what else do we have? See the time it takes to accelerate from rest to 1 day time average. We know that we have average velocities there. Anyways, small water now. That it's a small water. Let me just write it here. Time will be v over initial velocity divided by acceleration. 555 divide, obviously in kilometer, divide that by 3.6 will be 15,0 divided by 0. Remember, you convert that, since it's in kilometers, you divide by 3.6. Your velocity will be 15,278 meters per second. So 15,278 minus 0 is from rest. Acceleration is the one that we got there. So therefore the time 65,3 seconds. That is what we have. It's our time. All right. I think this let be the last one. If you have subscribed, guys, I will continue tomorrow with other examples, so and so on. Because I also now I'm thinking of, I also have to do N5 Tractive. I have to let me all. I must also place them a little bit. And have to project them a little bit. Have to plug in them a little bit also, so that everyone will be happy that way. Make sure, guys, you have subscribed anyways. So this one, I think it's a basic question. Okay, let's check. A locomotive has a mass of 60 tons, 70%, which is supported by the driving wheel. If the tractive resistance is 80 Newton per ton, the coefficient of friction is 0,5. Determine the drawbar pull when the locomotive is level. Level when ascending. All right, this is an okay. This question, I think I saw this in N5. Okay, I remember draw pull, the one that's supposed to minus and stuff. Because the draw pull is like, because the draw pull, if I have the locomotive in the horizontal surface, let me just do this. All right, let's say I have my locomotive there. It's traveling. There is a level surface going in this direction. If it's going that direction, I will have TE It is fun anyways. We'll have TE. It is fun that we'll have TE. Now if I have a draw pull here, I will have our FR. But now draw pull will replace acceleration. If I have draw pull, I won't have FA. I will replace FA with a draw pull. This instead of FA will be a draw pull. FD. This will be a draw pull. So from that can say TE using the equation. These are acting in the same direction. It's draw pulley. I will just say FD draw pulley plus FR. Now I want the draw pull. I make the subject the draw pulley. The subject. Therefore, draw pulley. If I take that, is like TE minus TR. So this is our draw pulley. Replace FA. We stand together. Okay, it's fine. No problem. FD, TE, can calculate TE and do that. At least now we have a track what is going on. We have a schedule there. What is going on? Yes, you see there. Please do not put acceleration. Accelerating force. Okay, now let's calculate TE because we have seen that it will be demanded there. It's mass of the locomotive multiply by coefficient, multiply by gravity, multiply now by the percentage. Let me just do like this: percentage mass on driving. I won't go wheel on driving. I won't write it in full. I'm lazy to try to. Let me just say percentage mass. We know that, guys. Anyways, mass of the locomotive is 60 tons. Must be in kg because this is mass. Must be in kg. So 60 times 10 to the power of 3. Converting that. Coefficient of friction is here. 0.25 multiplied by gravity 9.81. Then this the mass there on the draw, or multiplied by 70%, which is 0.7. Therefore TE will be equals to what? Punching this, supposed to get 103.005 Newton. Then we have seen that, guys. I've shown you draw pulley must be TE minus FR. So we're supposed to get again FR. FR, we know it's the mass of the locomotive multiplied by the rolling thing. Mass of the locomotive, at least all of them, they're in tons, so there's no worry. We'll simply have this minus this. So let me just substitute this one time. I don't have time for that anyway. Let me just substitute it here. FD will be TE minus FR, is the same as mass of locomotive multiplied by R. So it's the same time mass 60. The rolling resistance 8. Then we have this draw pulley will be equals to what? Then punching this. 98205 newtons. That is your draw pull. Then when accelerating at the not grade, they wanted to say gradient of 1 in 75, this is a slope accelerating. Oh my god, my drawing there, it's so ugly. But anyways, you know the gradient 1 is to 75. Then you have to find this theta by using tan, opposite of adjacent, or you can multiply by the slope by 1 over 75. You can multiply by the slope, or you can find the angle. If you want to find the angle will be tan. You say 7, you put 75 or 1 over that. I think, I don't know, yeah, or it will be 75 into 1, or maybe 1 will be the mark. 75, 1 will go up. Okay, it's fine. So anyways, let me not rub the triangle. Let me not erase it. Either way, let me not erase it. You can say here we have our remember TE in this direction, ascending. Here we'll have, don't forget the gravity, or FG. When you have the slope, do not forget your friction, rolling. We're supposed to have FA, but now will be replaced. Remember, we're talking about the will be FD. We are talking about drawbar pull. Drawbar pull will replace acceleration with the drawbar pull. So from this we'll have TE will be equal, these are acting in the same direction, is same as FG plus FR plus FD. But want the draw pull, if you want the draw pull, you see you have TE here, you subtract all of that, FG minus FR. So anyways, that is how the cookie crumbles. This is how the cookie crumbles. So that is how you can get this drawbar. We have seen that you subtract these three things, but not forget FG is equals to mass multiplied by gravity multiplied by the slope, or here. Anyways, okay, let's find the draw pull. TE minus FR. I've shown you why we ended with this. We've calculated this on the top. It's still the same thing. Did no 0.005 FR. We know it's still the same thing. It will be that mass of the multiplied by R. If we 60 times 8 be 480 minus 480, 4,800 by the way, man. Then minus FG, take note, I said FG, it's mass multiplied by gravity multiplied by the slope. So mass there of the locomotive, remember it's in ton, but now this must be in kg, times 10 power of 3, gravity 9.8. slope is 1:75. So anyways, punching that, don't know, but for me, sorry about that. For me, I got, oh, what I'm doing, what the heck. For me, I got that FD, punch this, all of this. Support to get your draw pulley, guys. By the way, we together would be 9,357 Newton. So that is it. That is what we have in this topic. So guys, if you want some more questions, I'll be posting here. If it's your first time watching my video or you have not subscribed to this channel, please subscribe and click the notification bell so that you'll be notified whenever I post a new video. All the best. Thank you for watching. Don't forget to comment and to like and to share this to your fellow classmates. All the best.